Hello, I'd like to welcome you to my presentation on long fiber wood compounds. My name is Thomas Schmidt. I'm a research associate at the Rosenheim Technical University of Applied Science. So to start right in, I want to give you a quick overview about our main research topics. Me and my colleagues are working on products and processes concerned with TMP fibers. We are dealing with flexible wood fiber insulation or even rigid wood fiber insulation. We do wood fiber nonwovens. The project I'm working on and I'm concerned with are wood fiber thermoplastic compounds. And we also have projects about hybrid components. Now for wood fiber reinforced thermoplastics, we use TMP fibers that are really long and slim. We use wood fibers instead of glass fibers or carbon fibers or other natural fibers like henequen to reduce the cost, to reduce the weight. And another advantage of the wood fiber is that they are available throughout the year and through all of Europe or Germany. And those parts, like you see on the bottom in the picture, are especially applicable and requested by the automotive industry, for example. For our wood fibers, we use spruce wood that is locally harvested here in Rosenheim. We make TMP fibers out of it. We produce the TMP fibers at our laboratory scale refiner, where we have several 12-inch grinding discs, like the one you see in the picture. We cook the wood chips at around 150 degrees centigrade for about 3 minutes, and we have a steam pressure in the cooker of about 3.8 bar. The compounding is done in an injection molding machine, where we have a twin screw direct compounder. We use polypropylene granules with a very low viscosity, and the fiber infeed is via side feeder. The whole screw is heated up to 190 centigrade to melt the plastic and mix all together in one shot. So we can, until now, use up to 40% TMP fibers by weight in this machine. So the picture you see at the bottom is one of those two screws. We have several elements that can be exchanged and varied depending on the usage, where you can put in screw elements with a steeper angle, for example, or other cutting elements. Here you can see first results. We compared WPC, sawdust-filled WPC, with our long fiber wood compounds from 10% to 40% of fibers in the thermoplastic matrix. You can see a definitely increase in tensile modulus, and even the tensile stress increases from 10 to 30%. Directly compared to 30-40% of sawdust in the compound, you can see higher tensile modulus and even higher tensile stress. So in conclusion, if you compare a standard WPC to our long fiber fill composite, one could state that the mechanical properties are increasing by the amount of wood used. We can see a high potential in using TMP fibers in the application of enforcing a polymer, and as well as the twin screw compounder is necessary to really blend the compounds uniformly together. Another thing we also did was using a foaming agent in the process that really reduced the density of the product while only slightly decreasing the tensile stress. For my last slide, I want to show some prospects, what we're also working on. We use thermoplastic wood fiber nonwovens that are densified, preheated, and inserted into the injection molding machine, where we also injection mold this LFWC, these long fiber wood compounds, onto the surface to get a hybrid compound that you can see on the bottom right. It's pretty interesting because you can apply functional elements directly on the nonwoven to have a good application, maybe in the automotive industry, for example. That's it for my presentation. I hope you enjoyed it, and for questions, I'm always open. Thank you very much.